With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem is simply reason and assertion type problems, and the first statement says in case of a stationary wave, a person hears a loud sound at the node as compared to the antinodes. And the statement 2 simply says in a stationary wave, all the particles of the mediums vibrate in a phase. So let us first try to analyze the statement number 1. For that, let us try to draw the diagram of the stationary wave. So you can see here I have drawn a stationary wave. Now how a stationary wave is formed in a medium, right? Let us suppose that this is the incident wave, and when this incident wave is reflected from a boundary, now the boundary could be of any type, right? Then this is the reflected wave. So due to the superposition of incident and reflected wave, this is your incident wave, and this is I'm taking as your reflected wave. This is your incident wave, and this is your reflected wave. Due to their superposition, what is happening is that a stationary wave will simply result in a medium. Now let us try to see what will happen. So this is simply a node. This is simply called a node, and this point, or you can say that this point, is simply called as anode. Now let us try to examine what will happen. What are the pressure variations at node and antinode? So similarly, I can say that this will be a node, and again this will be an antinode. Now let us see that a disturbance is traveling in air. I'm talking about a stationary wave in air. So this is an incident wave, let us say a disturbance in air, and then this is a reflected disturbance. Due to their superposition, this is a stationary wave which results. Now let us try to see what will happen. You can see that if this is air, then what happens is that the displacement of particle is simply maximum at antinode, right? So you can see that when the air molecules are far apart, right, we call this point as rarefaction, right? And the rarefaction means minimum pressure or less pressure. So this is a point of minimum pressure. Similarly, if you see at this point, at this node, right, or at this point, you can see these at these point at node, what is happening is that air is simply compressed. You can see that air is forced to compress at this point, right? So there is simply compression. Now, what is the meaning of compression? Compression simply means high pressure. This is simply high pressure. So you can see So you can see here what happens is that air is simply compressed from antinode to node. So I have proved that at node there is high pressure, and at the antinode, since the displacement between the air particle is maximum, so the pressure will be simply minimum, because it will be a point of rarefaction. And at node the air will be simply compressed, right? So the air molecules or particles will be very close to each other, so there will be compression and high pressure. So definitely what we are going to get is a loud sound. Due to this, there will be a loud sound, or so there will be loud sound at node as compared to the antinode. The statement 1 is simply true. Now let us try to examine the statement number 2. Statement number 2 says in a stationary wave, all the particles of the medium vibrate in phase. Now what is the meaning of phase here? First, let us try to be clear about the phase. Now a particle is said to be in a phase. What happens is that when its speed and its direction of motion are same. So let us suppose that we have two particles, one is P and the other particle is Q. They are said to be in same phase, right? When what happens is that their direction of motions and their speeds are simply same, then they are said to be in phase. Now let us try to examine a stationary wave. Does this happen in a stationary wave that all the particles in a stationary wave are simply in same direction of motion? Now this is not true. Let us take an example here. Does this happen in a stationary wave that at an instant what is happening is that all the particles are simply moving in the upward direction, right? We can say that in a stationary wave all the particles are in same phase if at any instant all the particles of these loops are simply traveling in a same direction, right? None of the particle is traveling in other direction, right? In downward direction or anywhere else. So all are traveling in the same directions at all the point of this stationary wave. Then we can say that in a stationary wave all the particles of the medium vibrate in a phase. But you can very clearly see that in this loop, if the particles vibrate in this direction, then the other particles may vibrate in this direction. So in adjacent, or in, you can say that the in alternate loops also there are particles which will, you can see that in this loop also there will be particles which will vibrate in this direction. So what happens is that you can see that their phase will be simply opposite. So this statement simply is incorrect, that in a stationary wave not all the particles of the medium vibrate in a phase. So in that case, statement 1 is true, but the statement 2 is false. This will be the correct option. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.